Hello wonderful person, this is Anton, and today we're going to be discussing a somewhat fascinating discovery coming from the nearby Large Magellanic Cloud, a satellite galaxy of the Milky Way. And that's because approximately 6 years ago, on December 18th, 2019, astronomers noticed something very unusual. A single star in this galaxy briefly got very bright for approximately 1 hour, returning back to its original brightness afterwards. Except that in this case, this was not a supernova and not a solar flare, and instead was a very exciting event that technically connects directly to Einsteinian principles. Because this was a smooth, symmetrical rise and fall of light, we know for a fact that this was a gravitational microlensing effect. The effect produced by some kind of a mass passing in front of the star and making it appear slightly brighter for just a little bit. And so now, approximately 6 years later, this event has been analyzed and nicknamed Phoebe. But interestingly, its existence and its detection now actually has a slight chance of possibly solving the mystery of dark matter. And so let's discuss exactly what was discovered and why this is so exciting, and also talk about some similar events in the last few years. But before we look at the discovery, we obviously have to understand exactly how this is done, because microlensing in general is one of the most elegant predictions of Einstein's general relativity. And while normally, when using telescopes, we can only see objects that emit light and objects that block light, for example, different types of nebula. But we also know that sometimes gravity itself can also act like a lens and dramatically increase the brightness of an object if things are positioned in just the right way. And so when some kind of a massive compact object passes directly between us and a distant background star, the gravity bends the light rays coming from the star in such a way that all of it becomes magnified by several times. And depending on how long this lasts, and also depending on how bright the star gets, researchers can then work out exactly what kind of an object this is, and in some cases even find additional objects orbiting around it. So for example, here we can find a star and an exoplanet in its orbit. And so generally, the lighter the object passing in front, the faster the event happens. For example, if this is something that's relatively massive, such as a brown dwarf, it might create an event lasting for several days or even weeks. But if this is some kind of a planet, specifically a much smaller planet, this might last for a couple of days or maybe even just a few hours. As a matter of fact, if this is some kind of a star that's difficult to see, it might even create a lensing effect lasting months. But for Phoebe, for this bizarre object, this surprisingly only took 60 minutes. In other words, the entire gravitational lensing effect was extremely short and technically the shortest we've ever seen. Which is one of the reasons why it was missed initially. Nobody expected such a short event to be discovered by these surveys, and so it was actually the reanalysis of the data that finally confirmed its existence. And in this case, the actual detection was made by a team from the Swinburne University, focusing on the data from the Dark Energy Camera, an instrument whose main purpose was to study dark energy by detecting various lensing effects, but by also detecting supernova. It sort of looks like this. And so here the team behind the study was actually performing a high-speed survey of the Large Magellanic Cloud, the satellite galaxy of the Milky Way. But unlike other surveys, here every single picture was being taken every 50 seconds, mostly because they wanted to catch very fast events. And one of the objects discovered was this Phoebe. But when they analyzed the light curve, they also found something remarkable. Based on this 60-minute duration, they were able to calculate the mass of the object, and it actually seems to be only 3 masses of the Moon, or approximately 1/30th of planet Earth. And it's really this part that makes this kind of bizarre. Okay, so why is this strange? Well, because there are now 3 main possibilities of what this object seems to be. The first possibility is that this is some kind of a free-floating planet in the Milky Way galaxy, or basically a tiny rogue planet that's just a little bit bigger than the Moon, and that to some extent does not make a lot of sense because it's just so ridiculously small. Here, trying to explain its origins, or why we were even able to detect it, would be actually kind of difficult because it's an extremely unlikely event. Alternatively, if this is not in the Milky Way galaxy and is instead inside the Large Magellanic Cloud, it might be an extragalactic planet, meaning that this is the first exoplanet we discovered inside the Large Magellanic Cloud. which in this case would be also very exciting because detecting such a small object is just ridiculously difficult. But it's that third explanation that is just a little bit more exciting, and surprisingly is also just a little bit more likely. It could be a primordial black hole. Something that a lot of scientists have actually been speculating for a very long time, and something that a separate team even looked for in the Andromeda galaxy approximately 5 years back. And the reason this is exciting is because, according to Stephen Hawking and actually a lot of other physicists, one of the potential explanations for the mystery of this dark matter phenomenon is really the fact that the entire galaxy is actually filled with these relatively small in size black holes that are much less massive than the Sun and are potentially planetary or even asteroid-like in mass. And by having trillions and trillions of them in a galaxy, you would actually account for the entire mass balance of that invisible dark matter. And because we're talking about black holes, and black holes that are not interacting with anything, that's why we're not actually finding them. And since a lot of these black holes are expected to exist in all of the galaxies, including the Large Magellanic Cloud, there is a slight chance now that this is possibly one of these objects. Or essentially, the astronomers from this study are now actually leaning toward that third explanation the most. And so just to, clarify this, these are not standard black holes produced from supernova, but are actually primordial black holes that are billions of times less massive and very likely formed in the first moments of the universe following the Big Bang. Basically as a result of a direct collapse of a lot of mass in those first few moments of the existence of the universe when everything just started. And once again, this is exactly what Stephen Hawking actually proposed back in the 70s, and what he tried to use to explain the phenomenon of dark matter, with a team in the study calculating the probabilities and discovering that Phoebe is 100,000 times more likely to be an object of dark matter than a normal star or a planet. And that's actually a really unexpected result, because if Phoebe is indeed a primordial black hole, and it has been drifting silently through space for 13.8 billion years, it means that this is the first time ever it announced itself for just one single hour for 60 minutes back in 2019, and is going to remain invisible and silent for billions of years to come. In other words, we got super lucky to even see this object, independent of what it actually is. But as I mentioned in the last few years, this is obviously not the only unusual detection, and this technique of microlensing has only been getting better and better, with scientists actually discovering quite a few objects that are just as exciting. And that's because in just the last 10 years, this field has evolved dramatically. For example, back in 2022, researchers using the Hubble Space Telescope reported the first unambiguous detection of an isolated stellar mass black hole. A black hole that's a little bit more stereotypical, formed as a result of a supernova, and a black hole that was relatively massive, 7 times the mass of the Sun. And in this case, it was actually detected through the use of a kind of a wobble of the background star instead of just increasing brightness. In other words, the star actually shifted its location and moved just a little bit because the gravity from this black hole was shifting the light. And so this was also an extremely exciting discovery and the first of its kind. Then, last year, researchers have also confirmed the existence of a Saturn mass planet, or basically a gas giant that was completely by itself, a free-floating planet or a rogue planet. And this was actually a major breakthrough because astronomers used what's known as a parallax effect, or basically observing the object from 2 separate locations, in this case from planet Earth and from the Gaia telescope, with 2 observation points being millions of kilometers apart, which actually allowed astronomers to locate this object extremely precisely, which made this one of the most exciting, most accurate observations of a gravitationally lensed object located right here in the Milky Way galaxy. It was also interesting because it was a relatively massive planet and was most likely produced by violent dynamical processes when young star systems evolve and when they basically end up throwing off some of the planets, ejecting them into outer space because of the interaction with other gas giants. And something like this very likely happened in the solar system, with a somewhat similar planet thrown off into space a long time ago. But this Phoebe object is definitely right now one of the most exciting ones. Once again, because right now, statistically, it seems to have the highest chance of being a primordial black hole and not a moon or a planet, which would definitively confirm that dark matter is not just some kind of a ghostly particle, but could indeed at least partially be made out of primordial black holes that are much smaller in size. In this case, it's a lunar mass black hole, basically only 3 masses of the moon, which in terms of size is even more mind-blowing. If this is a black hole, it would actually be only like this big in size, 0.6 millimeters. And so yeah, if this is a black hole 3 lunar masses in mass, its overall diameter would only be 0.6 millimeters, which is just a little bit thicker than a typical pencil lead. And so the fact that Phoebe was detected at all is actually very significant. First of all, because this is really at the limit of what we can even detect, and second of all, because additional surveys, including the surveys by the Subaru telescope, seem to have also discovered very similar candidates that have not been confirmed yet, and specifically candidates in the Andromeda galaxy, which might contain an entire population of these lunar mass objects that in reality represent the mysterious dark matter. But I guess the next question is, okay, so what's next? Well, first of all, the bane of all microlensing events is that they generally only happen once. So basically we cannot go back and look at Phoebe again because this lens has already moved on, and it's not going to happen again for a very, very long time, possibly even a million years. Which means that we need to find a similar object somewhere out there that can essentially confirm the existence of this new type of an object. These tiny, tiny black holes that are potentially all over the place. And this is where new telescopes like the Nancy Grace Roman Telescope and the Vera Rubin Observatory are most likely going to help us quite a lot. These telescopes are going to be monitoring millions of stars with incredible precision and will potentially detect thousands of these microlensing events, allowing scientists to build a statistical map, which then will help them figure out exactly what this is and if it's dark matter after all. But these telescopes are expected to find anything from tiny planets to relatively large rogue black holes that are just not producing any other energy and are only visible when they bend the light. And so until future studies and until future observations, we're not going to know much more. But even here, Phoebe reminds us that the universe is mostly filled with things we just cannot see. Whether it's rogue planets that lost their star system a long time ago, or black holes traveling across space and not interacting with anything, this new detection of Phoebe is just a tiny window into this galactic underworld that even today we still have trouble seeing. And that of course means that for astronomers, there are going to be so many new things to discover as telescopes become better and better. And so until those future discoveries, thank you for watching, subscribe, come back tomorrow to learn something else. Support this channel on Patreon where you can find additional videos without any ads and can DM me directly, or by joining a channel membership that grants you early access. You can also support this channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.